Hello everyone, and welcome back to the Geotech Master channel. I'm so glad you're here. Today we're exploring a really important topic for anyone working with the ground beneath our feet. That's right. We're talking about developing a geophysical testing plan. If you want to learn how to investigate a site's subsurface properties using geophysical techniques, then you are in the right place. In this video, we'll tackle some key questions I'm sure many of you have asked. Questions like, what exactly is a geophysical testing plan? Why is it such a critical part of any big and especially long geotechnical investigation? How do we choose the right geotechnical investigation methods for our site? And how does all of this work to help us better understand what's going on under the ground? We will try to answer all of these questions and more. So stick with me until the end. Before we get started, a quick note for those of you who are new here or haven't yet completed the previous course, Geotechnical Investigation Essentials. This video is a continuation of that course, and it really builds on many of the key ideas we discussed in that course. If you haven't had a chance to watch it yet, I would really encourage you to go back and check it out first. It is very important that you have that basic knowledge first. Don't worry. I have included a link in the description below to make it easy to find. Once you are up to speed, come back and join us here. So, let's jump in. What are geophysical investigations exactly? Well, in simple words, these are techniques we use to learn about the subsurface conditions of a site by measuring and analyzing various things from the ground surface or within boreholes. We're talking about things like seismic, electrical, electromagnetic, gravitational, and magnetic fields. It's a bit like giving the Earth MRI scan to see what's hidden beneath. These methods are great because they allow us to look at the big picture without digging everywhere. Why is it a good idea to start with geophysical methods? Well, surface geophysical methods are particularly useful during the early stages of a site investigation. They allow us to get a quick overview of the subsurface, understand the stratigraphy, that is, the different layers of soil and rock, and also help us pinpoint potential anomalies or unusual areas. Once we have this initial picture of what's going on, we can use the information to decide where we should focus our efforts. This means we can optimize the locations of our subsequent borings and soundings, making the whole site investigation much more efficient and cost-effective. Imagine this: if we did not use geophysics to look at the big picture first, we would be doing investigations blindly. But with geophysics, we are more confident that we are investigating the right areas. Now, it's really important to understand that geophysics is only one part of the puzzle. It's most effective when it's followed by a more targeted program of in-situ tests, drilling, sampling, and laboratory analysis. Think of it as a multi-layered approach. By combining geophysics with these other methods, we can build a detailed and reliable conceptual site model for the project. So, how do we go about creating a geophysical testing plan? Well, when you are developing the scope of a plan for subsurface investigations related to planning, designing, and constructing facilities, you will want to consider the following points. Select the appropriate sampling equipment and borehole advancing methods for the anticipated subsurface conditions. Select the appropriate type of measurements to evaluate groundwater conditions. Select the appropriate scope for laboratory testing and the appropriate laboratory tests. Your project's type and overall scope will dictate which components are needed to develop a proper ground model. But what are the general guidelines? First, it is essential that you review the existing information, including the available records, and then conduct a site reconnaissance. This will allow you to understand the local geology, the past activities at your project site, the potential variability in subsurface conditions, and the likely performance issues you need to evaluate. Based on the site reconnaissance report, you will now understand what types of data you need for your project. You can then look at geophysical testing. Geophysics is very useful for determining the physical properties of the subsurface, including stratigraphy and the location and size of potential anomalies. Geophysical testing is usually conducted in initial phases of a project because, as we saw earlier, this helps optimize the locations of subsequent borings and soundings. So, how do you choose the right geophysical method? Well, that really depends on the information you are looking for and on the specific conditions of your site. For example, if you are interested in stratigraphy and you are not too concerned about high-resolution subsurface information, then seismic refraction or electrical resistivity methods might be good choices. On the other hand, if you are looking for high-resolution information, such as underground voids, electromagnetic methods may be more suitable. The point is, there is a variety of methods available, and the selection will depend on your project. What does a complete geophysical testing plan look like? It should have several elements that we need to consider, including clearly state what you hope to achieve with geophysical testing. Clearly explain the specific geophysical methods you plan to use. Include the exact locations where the measurements will be taken and the spacing between the measurements. In addition, we should list the equipment and instruments we'll be using, outline the roles and responsibilities of the field personnel, and estimate costs and timeline for the geophysical survey. Having a good geophysical testing plan is essential to ensure that the geophysical survey will meet the project objectives and that the overall subsurface investigation program will be as efficient as possible. So, remember, a geophysical testing plan is just one component of a larger subsurface investigation program. These investigations also include selecting the number and locations for in-situ tests, drilling and sampling, determining the minimum depth of investigation at each location, determining the required types of samples, and the sampling frequency, developing an in-situ and laboratory testing plan, and developing a plan for evaluating groundwater conditions. So, that is it for this video. I hope this was a helpful guide to developing a good geophysical testing plan. I would love to hear about your experiences and feedback. Please share them in the comments section. If you found this video useful, please subscribe and like to introduce it to more people. That's how you can support us in continuing our journey together. If you also want to support us financially, you can purchase this course, which has the slides of the presentation and the mind map of this topic, so you can learn it more quickly and easily. I will also provide the related resources in the package for your convenience in response to appreciate your support. Remember, links to the previous course and related videos are all in the description below to make it easy for you to get the information you need. These are also some references that I have used to prepare this course. Thanks for watching, and I'll see you in the next video.